Hey everybody, today we are starting in on section 2.3 with real zeros of polynomial functions. This is going to be part 1 because it's a little bit long in the whole thing. So we're just going to do the first 2 pages today and we're going to get into the rest another day. So a couple of things. Long division of polynomials is used to divide two polynomials. It looks a lot like long division that you learned in probably 4th grade. We're not going to talk about the division logarithm today. Synthetic division is just a shortcut for long division. You may have learned it before, but we'll go over it again today. It's really fun. The remainder theorem says that if f of x is divided by a factor like x minus some number, we'll call it k, then the value of f of that value of k equals the remainder of that division. And the factor theorem says that if x minus k is a factor of f of x, if when f of x is divided by x minus k, the value is the remainder, I should say, equals 0. Okay, we're not going to worry about upper bound and lower bound. So let's jump in. So when we're talking about long division of polynomials, there's a couple of things. We know that if the remainder is 0, that it means it divides evenly. We also know that the rational expression is improper if the degree, or the highest exponent of f of x, is greater than or equal to the degree of what it's being divided by. We'll call that d of k. And the rational expression is proper if the degree of f of x is less than the degree of d of x. And we'll look at what that means in just a minute. So we're not going to talk about this, but before using either long or synthetic division, you want to make sure that you replace any missing terms with a 0 in descending order. This is super, super, super important. I cannot tell you enough how incredibly important this is. So make sure that before you start dividing, that you're looking at what you're dividing so that you can replace any of those missing terms with a 0. So now let's look at this. We're going to divide this f of x by this d of x. So keep in mind, we want to make sure it's in descending order and that we're not missing any terms. So this is in descending order, but if you notice here, we're missing a term. 3x the third plus 0x squared, because there's no x squared term, plus 4x minus 2. Okay, and then this, we're not missing any terms, so we don't need to replace it by 0. So let's go ahead and use long division right here. So we're going to take 4x minus 2. Oh, excuse me. Back up. We're going to take x squared plus 2x plus 1, and we're going to divide it into 3x cubed plus 0x squared plus 4x minus 2. Okay, so when we are using long division, I'm going to put those steps right here. The first thing you're going to do is divide the first term into the other first term. So what I mean by that is when we're looking and we're dividing this first term here, we're going to divide it into this first term. So x squared goes into 3x squared, we know we can multiply it by 3x times. So I'm going to put 3x on top right here. Notice how I'm lining it up with the other x values of no other degree. So now we go in this order. We divide, which we just did, and then we multiply back. And what that means is I'm going to take this value that I just divided and I'm going to multiply it into every single part of that divisor. So we go 3x times x squared gives me 3x to the third. The key here is we want these two to match. And then 3x times 2x is 6x squared. Notice how we're lining it up with the x squared terms, which is why it's so important that we had that 0 placeholder. And then 3x times 1 is just 3x. So we multiplied back. And now we're going to subtract. Okay. I say draw the line, change the signs, because subtracting everything means everything is going to be changing signs. So we've got 3x to the third minus 3x to the third. Those will cancel. That's our goal. If your first term doesn't cancel, you've done it wrong. 0 minus 6x squared gives me a negative 6x squared. And 4x plus a negative 3x is plus 1x. And then the last thing is we're going to bring down the term, or bring it on down. Okay? So we're going to bring down that minus 2, and then we repeat until we have nothing to bring down. So we're going to go back to the first term, into the first term. So now I'm going to use a different color. So we're going to say the first term divides into this first term. Well, x squared goes into negative 6x squared, a negative 6 times. Now we're going to multiply back. So negative 6 times x squared is a negative 6x squared. Negative 6 times 2x is minus 12x. Negative 6 times positive 1 is negative 6. Now we're going to draw the line, change the signs. That's our subtraction. Negative 6x squared plus 6x squared are canceled. X and 12x is 13x. Negative 2 plus 6 is plus 4. There's nothing to bring down, so this right here is our remainder. So the way that we finish off of this is we put our remainder up here at the top. So we say plus, because it's a positive 13. So we'd say plus 13x plus 4 all over, because it's our remainder, is still being divided by our original thing over here. So we're going to say this is x squared plus 2x plus 1. And this is our answer. All right, let's talk about synthetic division. Remember, synthetic division is a shortcut to long division. And we want to remember here, this tells you kind of what you should remember, that synthetic division needs to be divided by binomials in this form, x minus k. So if I wanted to divide by x squared minus 5, we should not be using synthetic division. So can we use synthetic division for this kind of thing? No, it can only be x minus k. So can we use synthetic division to divide a polynomial by x plus 4? The answer is yes. In this case, if x plus 4, this could also be written as x minus a negative 4, where negative 4 is that value of k. So for this example of synthetic division, we're going to set this up so that we can remember we're always going to look at what we're dividing and make sure that it's in descending order and there's no missing terms. So when I'm looking at this, 2x to the 4th plus 5x squared minus 3, are we missing any terms? Well, I don't see an x cubed term, because notice how we've got x to the 4th, nothing x to the 3rd, x squared, and nothing x. So we want to make sure we have those zeros as placeholders to our missing terms in descending order. With that said, what we're going to do now is we're going to set up our synthetic division. So we always take our value of k and we're going to put it out front in our box. So our value of k in this case is 5 because it goes x minus k. So k is 5. And now we're just going to take the coefficients 2, 0, 5, 0, and 3, just those numbers. So we're not looking at the full terms. We're just looking at the coefficients, which are the numbers. We're going to leave a space and draw a line. First thing you're going to do is you're just going to drop down that first number 2. Then what you're going to do here is now we're going to multiply 5 times 2, and we're going to put it right here. So we say 5 times 2 gives me 10, and now we're going to add down. So 0 plus 10 gives me 10 here, and then we repeat. We look at 5 in the box, and we multiply it times 10, and we put it right here. So 5 times 10 is 50, and then we add down. 5 plus 50 is 55. So we're going to multiply the bottom line by the box to get our next number again. So we're going to multiply 5 times 50. We get 250, and then we're going to add down. Oh, pardon, I'm going back. Sorry. 5 plus 50 is 55. Now when we multiply 5 times 55, we're going to get 275. Add down is just 275. Multiply again, 5 times 275. We get the next number is 1375. If we add down -3 plus 1375 is 1372. There's no other number, so this number right here is the remainder. That's a lot easier and less to keep track of than long division. Super, super, super helpful. Okay, so let's talk about the remainder and factor theorems. Okay, so to use the remainder theorem to evaluate a polynomial function, we're going to use synthetic division to divide f of x by x minus k. So that would be like the factored form. Then the remainder should be the value of the function at the value of k. So keep in mind, if this is x equals 5, this is our value for k that we're going to use inside of our box. And remember, for synthetic and long division, we always write this in descending order with any missing terms with the 0 as a placeholder. So we've got 0x to the third plus 5x squared plus 0x, because there's nothing here, and a minus 3. So again, we've got some missing terms here and here, so we put them in right here. So we're going to take this 5, my value of k that I'm looking for. That's going to be in my box for my synthetic division. And now I'm going to take my coefficients 2, 0, 5, 0, -3. And now we're going to do our same process of synthetic division. Bring down the 2, multiply with the box. Box is 5 times 2 is 10, goes right here. Add down, 0 plus 10 is 10. There's my new number. Multiply 5 times 10 is 50. Add down is 55. Multiply to the box. Get my next number. 275, add down. Multiply the box. And we get 1375, add down, and our remainder is 1372. So in this case, because we were testing, let me fix that for us, 1372. So we know that f of 5 is the remainder of all of this, which is 1372. So instead of plugging in 5 into all of that and evaluating, you can also use your synthetic division. So to use the factor theorem, here's what we need to know. We're going to use synthetic, again, the shortcut, to divide the factor x minus k, and if the remainder is 0, then we know x minus k is a factor of f of x. Okay? All right. So for example, if I want to know that x minus 1 is x minus 1 a factor of f of x equals x squared minus 1? So here's what we can do. We can divide, because remember, this would be like saying x minus k, so then k would be 1 in this case, right? So we're going to put a 1 here, and we're going to rewrite this with a 0 in our missing term. So we've got a 1x squared, a 0x, and a negative 1. We're going to bring down the 1, and now we're going to multiply again. 1 times 1 is 1. Add down is 1. Multiply 1 times 1 is 1. Add down. So negative 1 plus 1 is 0. This is my last number, so this is my remainder. So we know x minus 1 is a factor of x squared minus 1. All right.